Hello, my friends, and welcome back to class. This week's module, we are going to investigate what I like to call a synthesis, a combination of previous ideas that we've already encountered in this course, but it tells a wonderful story about our planet and how humans have woven themselves into the Earth system and how humans have impacted what we define as the environment here in GSC 120, or Concepts in Environmental Science Online. The big theme for this phenomena is a warming planet. You see, our planet is constantly dynamically changing, but how is it changing? Like, what is going on in our planet as we are now living in an age where we're starting to see a lot of these pronounced effects that humans have put into the Earth systems that impact the environment. But these impacts aren't always for the best. And we're the only organism on the planet that has drastically promoted and allowed these impacts to effectively run away from ourselves because we were not able to witness the phenomena earlier in our history. So let's get started. You probably have seen a lot of news stories. Probably in the last 10 years, you turn on the news, there's some kind of news story saying that there's dramatic changes going on, interactions. And this is something we talked about earlier in the semester. We see the rise of mega droughts in the American Southwest and the rise of more arid climates in let's say, the Middle East. Right now, we're currently going through a heat wave in areas that are typically going to be cooler during the summertime, such as our Appalachian region. Even organisms that have lived in a very specialized region, such as these lizards that are only found in high elevations of the Arizona mountains, are actually going extinct because the habitats that they live in have dramatically changed historically and those habitats have become unsuitable for them to live in. Other phenomena that are great lines of evidence that of global warming trends would be things like rising sea levels. These are phenomena that we can go outside and we can witness and experience ourselves, and that the data that they are generating supports and can be used as lines of evidence to confirm that global warming is indeed occurring on our planet, and that we can link these back to human impacts. Remember, our planet is a sphere. It's a Earth system, and it's full of interactions. We have the hydrosphere, which contains all of our water, either from the frozen glaciers of the Arctic Circle all the way to the open oceans, the river channels and catchments that lead into lakes and ponds, even the water that's trapped underground. Basically, anything liquid falls within the hydrosphere. There's a subsystem within the cryosphere and the geosphere. We are part of the biosphere as we are part of the animal kingdom. And so an anchoring sphere, one that interacts with all the others and helps establish those important feedback loops, either positive or negative, would be that atmosphere where all of our breathable gases can be found, our weather patterns, but most importantly this week, our climate. As seen right here in this nice little flow chart I made, so here is our hydrosphere. It again deals with ocean circulations, our rivers and streams, groundwater, lakes. In it, we have the cryosphere, where sea ice and glacier formation, ice sheets can be found. Some environmental scientists are actually starting to separate it. That's why you see this in two separate boxes. Me, I actually lump them together. The biosphere, all the life on our planets, and the atmosphere is our gas. But most importantly, our water vapor, ozone layer, and greenhouse gases are going to be our primary sets of data this week, and our lithosphere, where all the rocks and minerals and earthly functions can be had and observed. But earlier I mentioned that humans, we interact with the Earth system, and that we are the main drivers of the dramatic changes that occur all around us. When we allow for our impacts to become observable in the environment and negatively impact it, we can see the interactions between humans as part of the biosphere interacting with, let's say, the cryosphere. Our ice caps are melting at a accelerated rate because of our human impacts, such as pollution. The biosphere, deforestation is a really good example. We as humans, we need to be able to utilize resources that can produce energy. Well, one of the most basic energies is just being able to burn wood, start a fire, generate heat, and with that energy. And so humans can go in and dramatically disrupt global ecosystems just to get energy resources. We've also learned in other parts of the class, coral bleaching. If you're, say, swimming in the Caribbean and you're using a specific type of sunscreen, the chemicals that make up that sunscreen will actually be absorbed into the water column and cause the local water to become more acidic and cause coral die-offs. Even sea urchins are affected with this because humans are uh, have systems of agriculture and we farm our food, but then we also use things like pesticides to kill off pests and allow our crops to become much more successful. But it will then leach into the local water supply and eventually make its way out in the ocean and dramatically change that chemistry. And it's reflected that in the hydrosphere. The atmosphere is going to be our global warming phenomena for the week, and geosphere, the rise of deserts, because the changes of the atmosphere will cause certain regions to become much more dry. And so here's a nice schematic just to show you all these changes focused on human contributions, and that's our big theme for the week. You have the hydrosphere, atmosphere, geosphere, and biosphere, and the cryosphere. And then we also have what we call the anthroposphere, which is just humans. It's like a subsystem for the biosphere that directly refers to humans and technology, much like how the cryosphere deals only with glaciers. But they all interact. And it's a feedback loop system, and it's currently in disruption. And so global warming is a very broad term, but it can be an alarming term because global warming refers to the long-term increase of the Earth's average surface temperatures. Human activities since the Industrial Revolution are responsible for almost all the increase in what they call greenhouse gases. Things like carbon, nitrogen, methane. These are greenhouse gases that we're going to be studying this week. And these are produced by humans, especially in their industrial factories. They get pumped up into the atmosphere and then bond together with water vapor and changes the chemistry and how that atmosphere functions. And the largest greenhouse gas emissions actually come from here in the United States. Many people believe China, but or also sections of South America or even Southeast Asia with India. But really, a lot of it comes from the United States, unfortunately. And it's because we have such a long industrial history that dates back, mid to late 1700s, with the big fancy, say, Carnegie steel mills, um, and coastal colonies. But we burn these fossil fuels using so we can get electricity, energy, heat, and transportation. And with that, it produces greenhouse gas emissions. And along with transportation and agriculture, these are variables found in the phenomena. And different greenhouse gases will always have a different global warming potential. Really, we have to ask ourselves, how long do they remain in the atmosphere, and how strongly do they absorb and take on energy, and how do they distribute it? And this produces what we call a greenhouse effect. Um, so on the left side right here is a natural greenhouse effect, and then this is the human-induced equivalent of it. And the greenhouse effect is just the atmosphere's ability to trap thermal energy radiating out from the sun. Normally, the greenhouse effect is an essential process, and it keeps our planet in what they call the Goldilocks zone. It's like the story of Goldilocks and Three Bears, not too hot, not too cold, just right for life. But human activities produce all this extra greenhouse gases, which get trapped in the atmosphere. So traditionally, it's like this, but now it's more like this. The greenhouse gases are making this upper part of the atmosphere thicker, and so that radiation gets trapped more, and less heat escapes, making the planet hotter and subsequently drier in some locations, wetter in others. And that's one of the reasons why we study it, because this greenhouse effect drives the distribution of our climates and even weather patterns. Also, like as part of our history of learning more about the phenomena, well, we can take a look at things like climate science, the long history of it. You probably see those again, the news stories where everybody seems to be talking about the climate, but those news stories come out probably in the last 10 years. But climate science actually has gone all the way back into the 1800s, where early chemists and physicists like Fourier describes the atmosphere's contribution to planetary temperature, but there was really no actively way to test it. The technology wasn't there yet to be able to explore this phenomena. And that's one of the great ways about learning environmental science, even in an online classroom, because we have the technology now. We can tie up those loose ends. And as time goes on, we will also learn more about Foote and who observes variations in heat trapping effects of water vapor and CO2, our early conception of that protective envelope that makes up our atmosphere. And then as time goes on, Aurelius refutes angstrom, where they actually are able to differentiate lower and troposphere and upper troposphere and build that envelope, that stratification or layering, and define really what the atmosphere really is. But the magic doesn't really happen until, say, like the 1930s, and upwards into the 1950s, where we learned that the oceans are carbon sinks, and that human interactions are changing that large carbon sink. Um, as we work our way through, let's say, this week's assignment, we're going to use concepts that and experiments that were developed back in the 1950s with Ravel and Platts, being able to establish a layered model of the atmosphere that helps explain how heat and greenhouse effects work as a retaining factor. We'll then get into the 1960s and learn about what the Keeling curve is, which is just a rather large graph that allows you to compare and contrast atmospheric data. As seen right here. This is an example of a Keeling curve. As we can see that it curves up. Temperature increases as more, say, carbon dioxide is released into the atmosphere through human impacts. And this is the Keeling curve being tracked from 1880 all the way into 2019, and it's still going. And then we'll get into more progressive times by being able to use the phenomena to learn more about, say, paleo data. What were past climates like by looking at how greenhouse gases may have changed over time. Does our planet go through times of warmth and cooling, or have we gone from warmth, cooling to continuous warmth because of human impacts? Again, I think the big philosophy is this week's lesson is to introduce you to the phenomena, but then give you the tools to make informed decisions on how you interpret your learning journey this week and how you better understand the phenomena and be aware of it. It's all part of that scientific literacy and scientific awareness, and even data literacy, as we call upon previous knowledge. As research suggests, there's also tipping points. Here's actually a great way of tipping point, and that connects to my previous comment about how we go from cool to warm cycles, but now we're going from cool into warm and consistently warm. And that's because the regimes have changed, the feedback systems. Positive feedback would be, cool into warm, or excuse me, negative feedbacks would be cool to warm, as you're trying to get through and develop equilibrium, or the system state being set at a set point. But then with human impacts, we're constantly going from cool to warm to warm to warm. That's a positive feedback loop as we're constantly moving away from that set point dangerously. Some recent research um, suggests that we actually have surpassed that tipping point. There have been at least 25 tipping points documented in both aquatic and terrestrial settings, and climate scientists have documented it to the point where we hypothesize that we may have taken all those different tipping points and surpassed them all by 2020 to 2022-ish, meaning you are learning environmental science during and after the point of no return in global warming, meaning all the impacts that you're going to learn about have already occurred. Our climate is dramatically impacted, and there's no way of going back. To me, that's scary. And so the climate is changing. What about you? What are you going to do at the end of this lesson to help mitigate and lower your carbon footprint and learn more about the phenomenon and be able to take the data being presented to you, make an informed decision, and then articulate that informed decision into scientific communication? And that's our main goal this week, is take a look at some data, use that data as a driver to make your own decisions, and then take your own decisions, remove the bias, and ask yourself, what can we do better in the environment? So that way, our grandkids, if we'd ever decide to have grandchildren, or that maybe our neighbors' grandchildren, or, are we going to have a planet that our descendants, or even after the human populations disappear from the planet, will we leave something behind for the next generation? All right, that's enough of my soapbox and philosophy about this week's lesson. If you need any help, please reach out. I am always available by video chat during regular scheduled open office hours. You can send me an email or swing by my office. And have an excellent day on planet Earth.
Well, if you told me you were drowning, I would not lend a hand. I've seen your face before, my friend, but I don't know if you know who I am. Well, I was there and I saw what you did. I saw it with my own two eyes. So you could wipe off that grin. I know where you've been. It's all been a pack of lies. And I can feel it coming in the air tonight. Oh Lord. Well, I've been waiting for this moment for all my life. Oh Lord.